So today we're going to talk about DuckDB. DuckDB is a high-performance analytical database system. It's designed to be fast, reliable, and easy to use. And this is really the keyword here, right? So DuckDB is a fascinating project in that it strives to be the SQLite for analytics. If you go to the website and you hover over to the media section, you look at this, a few links here that you can I recommend to take a look at a few of them, maybe the database architecture seminar, maybe the case for in-process analytics, and maybe this one, the SQLite for analytics. Created for data scientists who want the lowest possible barrier of entry to use a database. So this presentation was given by one of the two creators. His name is Mark Rosworth. And it's interesting because he started his talk with two quotations that really stick out. The first quotation he said was that data scientists use databases if they're forced to. He said that, and it sticks out. And the second quote that this was not his quote, but he also quoted Hadley Wickham as saying this. Hadley Wickham, by the way, is the creator of ggplot, dplyr, a lot of the modern sort of R data science stack. A lot of the tools are actually by Hadley Wickham. The tooling are by him, right? So if your data fits in memory, there is no advantage to putting it in a database. This is what Hadley Wickham said, right? So here again, he says, if your data fits in memory, there is no advantage to putting it in a database. It will only be slower and more frustrating, end quote. That is by Hadley Wickham. And so he quoted that as well in his video presentation. So let's take a look at what DuckDB is, and then we can talk a little bit about what is fascinating, and then we go into the code and we run some code and look at some demo. All right. First of all, DuckDB is a relational. So when you hear me use the word relational, immediately you want to think about table oriented. So basically you're creating tables, and within tables itself you have columns. So, and within tables you also have foreign keys relating to other tables and other fields. All right. So DuckDB is a relational database management system, DBMS. So sometimes you hear me use the word DBMS, and that's what it means. Search for like DBMS. So in-process analytical database management system, that's what it means. And then you see an R in front of that. That's relational database management systems that support SQL with no external dependencies. So that's also another fascinating part. It has no external dependencies. I'll search for like external here, right? So if you just look at the design inspiration, and then we look at some code very shortly, but I want to give you a picture of like why this is interesting and why this is worth your time, right? So DuckDB has no external dependencies, neither for compilation nor during runtime. So for releases, the entire source code of DuckDB is compiled to two files, all right? And there is no database management system server software to install, update, and maintain. DuckDB does not run as a separate process, but completely embedded within the host process. For the analytical use cases that DuckDB targets, meaning anyone who is doing any kind of data science work in R, in Python, in SQL, in Julia, this has the additional advantage of high-speed data transfer to and from the database. Now, this whole thing sounds a little bit abstract. So let me slow down here and maybe actually look at some mental models here, right? So today, very commonly, if you have like a client application, this could be a website, this could be your website, this could be a mobile app, this could be anything, right? This is your app. We call it the client, right? Client is where you want to consume your API service or your machine learning service. It could also be a Jupyter notebook if you want to, all right? And then there's a server. So server is kind of the same setup, but then there is a server. This is a very common paradigm, by the way. So you have a server, and this is where it's serving your machine learning API. It could be serving your TensorFlow model. It could be doing something interesting, right? And then what happened is that very commonly you also have a database. So database, usually we draw it like that, almost like a pancake. Okay, so we have the database, we have the DB. So I'm gonna call it DB, right? And then since everyone almost, I mean, nowadays in 2022, almost everyone likes to use Postgre. So let's use Postgre for an example, right? Of course, this could also be MySQL, it could be Oracle, it could be anything else. But let's just keep it simple. Let's say Postgre. So you have your front end app, right? This could be, like I said, this could be Jupyter Notebook, right? It could be a Google Cloud app, it could be a iPhone app, it could be an Android app, it could be a website, and then there's a server. This is where TensorFlow is sitting. This is where machine learning is running. Then there's a database. In a notebook interface, you usually also have the same idea. You have the notebook. So this is a notebook, and usually what is the environment in here? What is the runtime in here? So usually you have R and Python. Of course, you can also maybe add Julia to it, but let's stick to R and Python because this channel is really we use a lot of R and Python, so let's use R and Python. And then what happened is there is the DB. So no matter what, right, this is an isolated process separated from the client and server. And so what you have is you have this paradigm where if you want to do something in R and Python, this is the DB. You need to transfer data between database with R and Python. So you need to transfer data between these, and same vice versa here. You want to transfer data between server and DB, and then client and server. And this is usually done with like an API call, and then this is usually done on this level, the API level. This is usually done either through an ORM, object relational mapping. If you don't know what this is, don't worry, I'll point you to other videos on my channel. You can watch more about that. And when you look at, let's go back to the website. What it says is that DuckDB, you see, typically a database would run as a separate process. So it will run as a separate process. You need to set this up, you need to maintain that, and then you would take your R in Python and you connect to the database and you try to interface with that. And it's problematic for a few reasons. First thing is that there is this data transfer cost to and from the database, right? So it's sometimes could be expensive, right, to make transactions to a database, pull some data, query some data, bring it back to R and Python, and then convert that thing from the database, that thing in database, convert that to an R object or a Python object. So serializing and deserializing. There's a lot of kind of overhead here, right? A lot of friction here. What else it says? It says that in some cases, it can even process foreign data without even copying. If you use the Python package, you can also run queries directly on pandas data. So this is what we're going to be looking at later, right? So if you want to actually follow along, you could just set up a virtual environment. You could do a pip install. And of course, if you want to see this example, pandas, you want to install pandas. So you want to say pip install pandas. And then the next thing you want to do is you want to install DuckDB. So why not just go ahead and do something like this, right? In my case, requirement already satisfied, so I already have that. If I do a pip list, you see that I already have DuckDB installed. So I'm not actually gonna even try to reinstall again. But if you don't have that, you want to go ahead and say pip install DuckDB. I assume you have pandas. If you don't, you want to also say pandas, just like that, pip install, because we want to see some examples in here, right? Otherwise, it's a little bit abstract. So compared to this paradigm, what DuckDB allows you to do, or what it tries to do, is that it does not run as a separate process, but completely embedded within the host process. So it's saying that, would it be nice if we could have the DB directly in this environment, completely embedded? And this could be, it doesn't have to be in R Python, by the way. If you think about, what about JavaScript? What about this is client, right? This is the web browser. This is JavaScript. This is something like WebAssembly, for example. These are all native browser stuff, right? Can you have an embedded database in here as well? So this is kind of the goals of what it's trying to do. It's really, really cool. Really, really cool. If once you understand the paradigm, it's actually really, really cool. Very profound of what it sets out to do. Okay. So for DuckDB, there is no DBMS server software to install, right? So in the Postgre example earlier, if you ever try to use Docker, for example, your machine learning API projects, you have your front end app, you have your machine learning API projects, then you probably have this extra Docker container running Postgre on top of a DB server or Alpine Linux, and then you try to bridge the connection using something like a bridge. There's a lot of this kind of overhead. And then you need to write a database connection in the client. You need to make connections in here. And then if you, again, like I say, if you're using Docker, you have multiple containers trying to talk to each other through different services running together. And then within this itself, if you want to take this DB, you want to bring them into R and Python, you don't just bring it like that. It's not something as simple as like just copy and bring it like that. So what you have to do is you have to set up a bunch of create tables command. A lot of you who grew up with MySQL or grew up with SQL databases, let's spell that correctly. You have to do a bunch of like create table commands so that you could replicate what is in here. You can copy that database into this one, and then from here you call your create table call, and then you port your CSV data over into the Postgre, and then you make a read table call, and then you finally write your query. Before you have to do all of this stuff, and then you can write query. Okay. So DuckDB is really trying to say this. It's trying to say that, hey, what if I could I could save you all of this overhead. You could just go from R and Python directly to writing query. That would be cool, right? Then you can make use of all the cool database technologies without actually having to set up provision of this different infrastructure. So the whole idea behind having no dependencies and being embedded is actually quite profound. Is that it's quite a big deal. So it makes it easy to do deployment and integration in all kind of build processes today. It doesn't matter if you're using JavaScript, WebAssembly. It doesn't matter if you're using R or Python. If you want an embedded database in your app, you don't want to set up a whole Docker container running a separate database server software, then I think you would appreciate the elegant ideas that DuckDB tries to bring in. Okay, I recommend that if you want a more detailed, a more thorough talk on this, go and read some of this media, go and look at some of this Reddit presentations. Some of them are quite long, 1 hour and a half. This is 1 hour, but I'm just gonna skip to you. I'm just gonna give you the summary of what it says here, right? So let's now that if you have this installed and you want to follow along, just I'm gonna maybe create another one here. I'm gonna just go to my desktop, create some notes as well. But I'm gonna just give you the gist of what DuckDB is, and then we're gonna write some code, right? So open up Vim, and I'm gonna just open up an empty buffer. So if you watch the video, Mark says there are 4 or 5 main issues for why data scientists avoid databases. Remember how I started this video by telling you that his quote here, right? Literally his quote. He says data scientists use databases if they are forced to. All right. And why is it? Why is it that data scientists try to avoid databases as or why do they see databases as adding friction to the data science process? Now, the first thing, just a summary, just a recap, is that it's difficult to install, right? Difficult to install. To set up, there's time involved. It's not necessarily difficult, but it takes time. Difficult to maintain. You need to maintain a database. There are also costs involved in it. There's time involved in it. Then you have the slow data transfer. That's also something that you see from the notes earlier, right? So you have to. There is a data transfer. There's time involved between transferring data between database to whatever notebook or server or client. All right. So there's the slow data transfer to from client. What else is there? There is a poor interface, the poor user experience, or poor developer experience, I guess. Poor developer experience, or sort of a poor interface with a client application. That's also another one, right? Application. So this could be our Jupyter notebook. It could be anything, right? Let me just set wrap so that it doesn't try to hide. All right. And finally, one of the other things about why data scientists don't use databases is that it's almost pointless. It's almost pointless for a single user, right? So the point being is that if you use the databases and you have multiple users working on the same database, it makes sense. But if you're a single user, it probably doesn't make a lot of sense. It's kind of pointless, or viewed by data scientists as kind of being pointless. But when you look at the design inspirations for DuckDB argues is that data scientists actually, they love databases. They just don't want to use it, but they love databases. And in their aversion to databases, they end up ironically re-implementing database management systems. So data scientists end up re-implementing DBMS, and they end up implementing them but poorly, right? So the kind of things that you see, like for example, if you use pandas or use dataframe, for example, or you use some sort of like deployer workflow, you're actually re-implementing the same database management system. You're doing some sort of select, you're doing some sort of ordering, you're doing some sort of filtering. You don't have any of the technologies of databases. There's no optimizers, no scaling, no parallelism, no out of memory computation. Everything is in RAM, right? You want to do some sort of query, you need to read everything in there, and then within your RAM, right, within your memory itself, this is the in-memory, then you try to do everything within the memory. There is no out-of-memory computation the way that a SQL database allows you to do, where you could just write a query and then execute on this server without trying to read everything into memory, right? And so data scientists end up using all these workarounds for what is maybe natively a join in database management systems, and then they fail to utilize maybe up to 50 years of R&D thrown into database research, a very big field of database research field, right? And it tries to re-implement a worse off database system just for the upside of having a good developer experience, just so that they could stick everything in pandas or in R or you know in whatever they're working with, right? Just so they prioritize good developer experience, a good interface over all the years of research and all the optimizations that you get from using database management system. Now I want to show you 2 ways of working with DuckDB. So just to get your interest, I'll first use the browser because it's very easy to set up. So all you need to do is to go to shell.duckdb.org, and then I'm going to go into the Python and I will show you how to work with DuckDB in Python. So I'm going to give you sort of a quick tour of DuckDB first, right, just to get your interest. So this is easy. I'm going to give you a quick demo, and I'll open up my terminal in Python, and then we're going to write some code in Python and see how it looks like once you download it. So make sure before you do that, make sure you go ahead and do a pip list. You want to see DuckDB, you want to see pandas if you want to follow along. So DuckDB is in here. If not, just go ahead and do the pip install, which is what I showed you earlier. Pip install DuckDB and then do a pandas. Okay, you can pause the video just for me to wait for you, and then once you're done, open up Python terminal and then just have that somewhere. Then we're going to go back to this shell.duckdb.org. Okay, so it says that it's connected to a local transient in-memory database. So I'm going to go and search for some data right now. I'm going to just look for my repo, and I know I have a lot of data in one of my repo in here called data analysis. So I'm going to click onto that, wait for it to load. So click into data input. So there's a bunch of CSV. I guess you can pick any one. Let's say we click the rise.csv. You can pick any one. Honestly, this is just a demo. I'm gonna go into one of the CSV. I want to show you how you can just immediately use SQL, SQL syntax, doing query using all of the benefits of having a database, but directly on a CSV without ever converting the CSV into a SQLite or what have you, right? So this is just a CSV. Mind you, I haven't done the conversion yet. It's still a CSV. It says it's too large. We can't make this file beautiful. That's okay. I'm just gonna click on the raw, and it's gonna give me the raw CSV. So what I want to do is I want to copy that raw. Actually, let me just see if I can copy the link address. I guess this will work. But once the raw is loaded up, you have something like this URL. So you want to just copy that, just Control C, copy, and then you can get back your shell.duckdb.org. You can actually have this also in here. And I'm going to show you how later, but let me just use this so you don't even have to do any installation. It's just the fastest way to show you a demo, right? I'm going to start writing some query now. I guess I'm going to say select. Let me just say select. And what do I want to select? I want to maybe just start off by selecting everything, and then you can put a from. This is very common SQL command. And then now I'm going to put everything in my string, and I'm going to paste it. Your browser may pop up and say that it's asking you to see text and images copied to the clipboard. This is for your own privacy. In this case, I'm going to just allow that, and it's going to be able to copy off that, and I'm just going to close it with a end quotation. So select all from this URL, which is the rise.csv. Now suppose this is huge, right? Now look at this. This is huge. Now how many rows of data there is? There's so many of them, maybe a few tens of thousands. All right. Now I just want to take a look at the first few sort of rows. So I can do that by going to limit 8. Let's say just take a look at the first 8 rows of data, and almost instantaneously you get the result. You say all of these columns, it tells you this is the receipt ID, receipts items ID. My internet is actually really slow today, but this should run in milliseconds, less than even a second, but you can see all of that. I'm gonna actually try to maybe show you that. So there's the receipts items ID. So these are data sets. These are transactions. When you buy rice from the supermarket or from the mini market, there are certain receipts items, purchase time, unit price. I live in Indonesia, and this data is actually collected in Indonesia. It's done by my team, me and my research team, and so the value here is actually in Indonesia rupiah. So rupiah is kind of the currency in Indonesia. So this is not in USD or Sing dollar, because otherwise it'd be crazy. You're looking at that price and you're like, what kind of where do you live in where rice are so expensive? So it's not like that, right? And because we live in Indonesia, so this is 128,000 is not a lot. It's actually about like close to less than 10 US dollar. You can inspect the data. You can sort of explore the data a little bit. Some of these rice, they're like maybe 2 kilos or 3 kilos of rice. So there are a few sizes, and then there is the smaller rice, cost you about $4, 3 to 4 US dollars. So again, these are not in the US dollar currency is what I'm saying, right? And so you see that it works, right? It says select all from, and then you put in a CSV file. Now, before you even do the conversion from CSV to SQLite, you can already do that. You say select all from limited. And let's say just now I was asking like how many rows of data is this even? Because look at that. I could scroll down and down and down. There's so much data, so much. I keep scrolling down. So I could maybe just do a quick, I want to get a sense of like how many rows of data are there. That's something I can use SQL statements, SQL statements for. So how do I do that? I could just do a count. So I could say select, and I could just put a wrapper count, and I can say count, and you could put them in separate lines if you want. So you could say from, if you want to be tidy, you can say from, like in separate lines. So earlier I put everything in one line. I could also have them in separate lines. I can select from, and then I'm gonna paste in all of that stuff earlier, just like this, and then I'm gonna say select all from. And if you want to say like where and put some conditions, you can, but in this case this is good enough. So I don't want to have any kind of conditional clauses anymore. I just want to say select count from, run that, 64 milliseconds. It tells you there are altogether 12,000, and that is so fast. Try doing that, having to convert this CSV file into a SQLite and then bring that into Python. Just think about this workflow earlier, right? Having to take the DB, do the create table, replicate that, and then take your CSV, create a table, and then from the CSV create into a SQLite, and then from there set up all of this stuff, and then do a connection and then write query. There's a lot of this kind of overhead that is not in here. This is all so easy. Select count from, straight up put a CSV in there, you get the results returned back to you. And it's using good database technology, so you could later on you could have like scalability and stuff like that as well. And if you want to just sort of try that, you could use a different data set, I guess, because I'm showing you this demo using Rise or CSV. But you could go and look into my data input, and you can find your own database. You can find your own CSV file. There's also some SQLite file. You can also use DuckDB with SQLite, of course. But I recommend you try and maybe use one or two of this other CSV. So how I do it with Rise or CSV, maybe try using some other CSV files. For example, one is the books.csv. So you can look at this one. See that this is 1.47 megabytes. It's also too huge. The files that are too big, you can't actually see the preview in here. But all you need to do is to click on the view raw, and it will load up the raw format for you. And all you need to do is to just copy the one from on the address bar. So you have the book ID, you have one, and then title Harry Potter and the Half-Blood Prince, Harry Potter number 6, and then J.K. Rowling 4.56. That's ISBN, and then ISBN 13. There's number of pages, ratings, counts. Okay, there's a lot of information. Again, this is also another very huge data set. But what you need to do is you just copy off that, and you can use SQL on that. Just to hit enter a couple of times to bring it up a little bit so you can see it. In fact, I think I could also maybe resize this window. Okay, its layout is broken out a little bit because I keep resizing the windows just to make it comfortable for you to see. Otherwise, you have to peer towards the end of the sort of screen, the bottom of the screen. All right, so you could try and maybe experiment with some of these extra new data sets that you find in here. There's a lot of them you can find from my GitHub repo. Just go to my GitHub and then click on data analysis, click on data input. There's a ton of them. So for example, this one, let's do this one. Okay, let's just do this. So let's say, for example, I want to count the number of books that have a high average rating. So I want to say how many books are there. So we could say select. I want to say how many books are there with an average rating of, let's see, there is an average rating, I believe it's in here, right? And some books are really good, 4.49. Some books are not as good. Some books are 4.22. The Hitchhiker's Guide to the Galaxy, not as well received as Harry Potter, for example. The Ultimate Hitchhiker's Guide, 4.38. So you can. This is 3.98, Bryson's Dictionary of Troublesome Words. There is another one, 3.9. So imagine I want to do a count on all the books that have an average rating of more than 4.5. So I could use SQL for that. So I could say select, and what do? I say select count all. I could count, I guess you can have in uppercase, lowercase, doesn't really matter. And instead of just counting the number of books that have an average rating of more than 4.5, I also want to find the average rating of those books. So I want to say find the average rating, and I can use average, and I would say ratings count, ratings count, and let me make sure I spelled that correctly. Ratings count is here. So that's the name of the column. So I said find all the books where the books have an average rating of more than 4.5, and then count the number of books count the number of those, how many of such books are there, and then what is the average rating for them. So when I say select from, and then you want to again put in the same URL. So in this case here, it would be books_c.csv. This is earlier is rise.csv. This is books_c.csv. And then I want to have a condition like where. So could have where, and where what? Where the average ratings. So average rating would be this one, right? So not to be confused with ratings on. Ratings on how many people reviewed that book, how many ratings are there, how many reviews are there, how many ratings are there. Average rating is like on a scale of, I guess, 1 to 5. I'm not sure if there could be minimum of 0. I'm not sure if any books have ever received a average rating of 0, but we can find out as well. We can just use the SQL minimum min to find out. But in this case here, I want to find any book that have an average rating of more than 4.5. I want to count how many of them, how many of such books are there. So I want to say where, let's spell that correctly again, where average rating. So you want to copy this, and then you could type that out, average rating, where that is above 4.5. Do I want to put equal, greater equal? That's up to you. I just want any books that is strictly above 4.5. So I'm just going to put greater sign. And then I want to say, and if you only put one, what about books that have very little reviews? Maybe books that have only 6 reviews and all of them are the friends and family. So in that case, the book will appear in here as well. So I want to make sure that the ratings have the book has at least received some statistically significant enough sample size before they're included in my count here. So I want to say something like ratings count, right? So again, the ratings count up here where and rating count is above, let's say, I don't know, 1000 or something, so that you can't game the system. Otherwise, you could just get your grandma, you can get your grandpa, your aunt, your uncle to sort of rate your own books, and you can publish a book, and your friends and family will just rate 5-star, and now you have very low ratings count, but you have a very high average rating. So here in this case, I'm saying that find books that have average rating of more than 4.5 and a ratings count of more than 1000, then count how many of such books are there and what is the average rating. So I can do something like this, and let me just put everything out there. And again, mind you that I have a very slow internet connection today, so this should be very, very fast. It should be done in, again, like maybe 1 second, but because of my connection, it's gonna take a while to just make this connection to that data. Later, when I use my Python, you shouldn't have this problem. So in total, you have 74 of such books. What is the average number of ratings on these books that belong in this category? So these are highly rated books, right? These are books that have high point of pretty high ratings count and pretty high average rating. So there are 76,000 of such. And suppose you wanna maybe make this number a little bit nicer, you could just round them. So you could just put up, click on up, and it would just give you all of that, and you could go back up to average, and I guess add a round, so something like round, and then you can say 2 decimals, so you don't have to see all of these 36486. That's all of that nonsense. So just say select count. See, this is actually really fast. This is 47 milliseconds. If you run it again, you could try something else. You see, this is actually very fast, right? All of this happens within milliseconds. Now, the only reason you see this massive, crazy delay is because of my intermittent internet connection problems. But this should be really, really fast. And in fact, you see it later when you run it directly in Python. Okay. So you see here, when I do a round average, it counts that, but now it just rounded to 2 digits. But this is how elegant is this? Is that you can do this on a CSV file. So hopefully by this point, you start to see why DuckDB also calls itself the SQLite for analytics. In that it strives for, or rather it aspires to, the kind of ease of use and kind of simplicity in developer experience. And in all of my time of doing software and data science, data engineering, I've yet to hear somebody say, oh, SQLite is so confusing, right? If I explain Docker to somebody, I expect that out of a crowd of 100 people, I expect 2 or 3 of them to say, oh, look, I still don't understand Docker, it's so confusing. But to hear somebody say, oh, SQLite is so confusing, that's very unusual. You almost never hear that, right? And that is quite a big statement, right? Because almost every other tools that we learn in the developer, the DevOps, or the data science, almost every other tools, I even hear about people saying that Git is confusing, for example, like people who maybe senior developer who tell me that until today they still find Git being confusing, or like how NumPy can be confusing with the arrays and stuff, or Jenkins, or CI/CD, but never about SQLite. Never about SQLite, right? Let's get back to the shell. And when you first set up all of this, when you first set it up, it says that you can also enter .help for usage hints. And if this looks familiar to you, it's because it's actually using the SQLite as well. So I think you can search for it. It says we use the SQLite shell to work with DuckDB. So if any of this looks very familiar to you, that's because you may have worked with SQLite in the past. Or if you have not, I have other videos that I talk about SQLite and go into a lot more detail. I even teach you how to convert the CSV into SQLite using like 2 or 3 lines of code. I'll point you to those videos. You can watch those videos if you want to learn more about SQLite. But you can also click on .help, and it will give you a lot of these examples. It'll tell you to list all the files, download a file, drop a single file. There's all of these things in here. There is also, of course, the example queries. You can also put examples. And they also give you a few remote scans. So these are similar to what we did earlier. We're also doing it remotely. We didn't have to download anything. We just put in there. But here they're using it against a Parquet file. So you see a select count from Parquet. There's also other joins. You can look at, like, if you want to do joins, you can say select this, join this, from where, see, group by, and stuff. Now, okay, we don't want to go too much into all of this because I feel like you could maybe experiment on your own. But let's now put this to one side and let's go to our terminal. Okay, so hopefully now you have done the installation for DuckDB and pandas. Installation should be really, really simple. Should take you less than a minute or 2. If you already have NumPy installed on your OS, it should be relatively fast. If you're using R, by the way, then if you're doing R, by the way, you could say install.packages, and you just want to put your DuckDB in there. So you should just do it like that, and then just run the code, install packages DuckDB. A lot of other languages are also very well supported. You just have to click into the installation, and it gives you, this is Python, this is R, Java, Node.js, Julia. In Python, your installation will be pip install DuckDB, and then you can specify a version, and then you can say import DuckDB, duckdb.connect, and then you can just execute that. Okay, that's really cool. R, you can say install the packages DuckDB, and then you write some of this select query directly in here within 2 or 3 lines of code. And then there's Java, there's Node.js, there's Julia, the C, C++, CLI, ODBC. So there's actually a lot of things here going on. You can, and I'm sure they will add more of that, right? So there's all these different environments, and you can use the one targeted to your kind of developer workflow. And then maybe if you want to use it in R and you don't know how to do it, and you want to ask questions and stuff, let me know in the comments, and I will I'll do one for R, maybe if there's a lot of requests for that. I'm gonna open back up Python. I don't even need the second window anymore, so I'm gonna just have one window, and now it's easier, it's clearer to see now. So you could start off by saying something like import DuckDB, and you can do this exercise in Visual Studio Code if you want to. I'm just doing my shell in my terminal because it's easier, it's more simple, and simple interface. There's not a lot of like menus and stuff, so you can see it better. So it's up to you though if you wanna prefer to write your code in Visual Studio Code, so you can do that. And then you could also say something like import pandas as PD because we want to see some examples doing that. And then I need a database. I need a CSV at least, right? So let me go to my downloads again. So I remember that I need at least a CSV file. I'm gonna show all the CSV files that I have in my downloads folder. So I have sports.csv. So I'm gonna just say head-1. That is gonna say print the first row of sport.csv. Okay, that's the first row. So I have the information. I can go up here and I can just maybe read that in there. So I'm gonna say df equals to pd dot read CSV, right? So you put in the name of the CSV. So in this case here, it's gonna be spot.csv, and I know that because I have sort of another window that show me all the CSV file in my downloads folder. I know I run this in the downloads folder. Just a simple one df. You could do a df describe. You see that this is just a simple data frame, right? So this is a pandas data frame. Now using DuckDB, you could do something like DuckDB, and then you can say DuckDB.filter. So you can say DuckDB.filter, and then filter, you can pass in the first thing is to pass in the name of the data frame. The first one, name of the data frame is called df, so we put a df, then we put a comma, then we say the next thing. So in this case here, there are a few things that I wanna, let's say there is a type. There's all kind of types in here, right? Now you see that the minimum is 1, the maximum is 24, right? I want to find all the types where type equals to 6, for example. Can I do that? So I want to say filter for all the rows where type equals to 6. I want to be able to do that. And I want to say filter. And if I were to run this, bam, now it's going to show me all of it's going to execute that query, and it's going to return all of that with rows where the type equals to 6. So it gave me the relation tree. It tells me this is the filter. It's doing a pandas scan. And then it's telling me these are the results column. So type is a big integer. So meaning it can be a 1 or 2 or 3 or 4. These are all integers, but it cannot be a 4.4 because those will be a double type. So this is a big integer. This is a variable character. So this is just a character string. This is a big integer, again, double. So it gives you all of that. Then it gives you a results preview. Right, it says, well, you may not have asked for it yet, but here's a result preview. If you were to go ahead and run that, this is kind of what you're gonna get. So it gave me all the different rows where that is equals to 6, and look at how simple the command is. It's just DuckDB.filter type equals to 6. And what if I want to take everything? So this is actually my own fitness tracking data. This is actually my actual MiFit data. It's not some online data source. I run maybe 3 times a week, and every time I run, I use a fitness tracker on my wrist, and this is data. These are data exported from that. If you want to learn how to build cool stuff using data exported from a Mi Band, I have another video. I'm gonna put that in the video description. You can go and look for it, and you can export your own wristband data and build some cool analytics app with it. Now I'm gonna go ahead and change this. I want to say, what if I want to use the start time or spot time rather? I want to say that when I have maybe perform an activity for more than, let's say, 600 seconds, that's 10 minutes. So I can say query for that, find anything where sports time equals to or greater than 600. And if I run that, now I'm gonna get all the results back. And this is the filter. He's going to tell you the relation tree again, the results column again, and he's going to give you all of this. Now, obviously, now we're just returning everything. So he's going to give you all the columns. But you can also do some sort of select where I want only a few columns. You can do a lot of those things. All right. So you notice a few things here already. Is that how simple it is to just get started. This is all. It takes no time to execute this query at all. It's incredibly fast. It has a very optimized query plan. And if you compare that to, for example, SQLite, right? And some people like to compare this to. It's like, how does that differ to SQLite? Now, SQLite, if you take this CSV and you convert it to SQLite, you can still use SQLite to do all of this. How do you convert a CSV to SQLite? It's actually something really, really simple. And I show you how to do that in one of my videos. I'm going to put the link there in the description as well. But SQLite and DuckDB, they are both embedded. That means you don't need to install any servers or manage a server or manage a cluster. Right, it's all embedded. It's within that, within itself. And in fact, that's the reason you can also say something like import SQLite, and you can also do that. I think like this SQLite 3, and it will still work, right? You could also just import that. So they completely embedded. You don't. They are both single file storage format, meaning when you try to export a SQLite into an external file, it would just be a single file. So it's very easy to install and transfer this to someone else on the team, for example. And DuckDB also has the same thing. It's also a single file storage format. It's very easy to install as well. But DuckDB, however, markets its core features to be incredibly fast. And also the fact that it works with pandas data frame without you having to convert from CSV to a SQLite or whatever, a database before you can perform query. That's great. And then it saves you from all the transfer. It saves you from doing this kind of data transfer and a lot of other reasons, but we've gone through those before. But SQLite is incredibly fast, and it's great for analytical processing where you're trying to do some data and you're trying to minimize transfer between R and Python and R DBMS. You don't want to do a lot of transfer between R and Python and R DBMS, so that's really good for all of that. Let's take a look at our rows here again. Let's say df.columns. Okay, so there is a type, start time, spot time, max pace. Okay, let's try and compose a more elaborated query. Let's say if you want to do something more elaborate, you want to do it in, let's say, a multi-line piece of query. So you don't want to, just now, you notice that my queries are very short. These are my queries. Spot time, greater 600, that's it. And then I said, oh, I want to take that, and I want to take more than 400, and that's it, right? But what if I want to take something and I want to write a multi-line SQL query, probably more closer to real life? How would you do that? So we can compose a query string. You can name it anything you want. I'm going to make it a triple line here to make it multi-line string. And then I'm going to say select, and actually we have it here. So the great thing is that we have this window. We can also see what do we want to select from here. So I want to select, in this case, I want to select the type again. And then I want to do some sort of group by. So I want to say for each of the group, so for each group of activities, I want to find the average time. So let's say type 1 equals to yoga. I don't do yoga. I'm very inflexible. But let's say type 1 is equals to yoga, and then type 2 equals to running, and type 3 equals to swimming, and then type 4 equals to cycling, right? So I want to see what is the average time I spend on each one of these activities. So what is the average time I spend on yoga? Every time I do yoga, what's the average time I spend on cycling? What's the average time I spend on swimming? And what's the average time I spend on running? So I want to say select type, and I want to say take the mean. You can also use the average. So it's the same thing. You can say average, and I want to take the spot time. In this case here, because it's spelled with T capital, you want to do that as well. And then I want to maybe just give it a quick sort of an alias. So I don't want to having to type this whole thing out there. So I want to just say maybe activity time average. Maybe like this, right? And then I want to say from, then what is the name of my data frame up there? I name it df. And so I name it df. So I want to paste from df as well. And so df is already a data frame. Oops. And then accidentally added a line there, but that's fine. You can say where there is a type here. So if you said hit, take 3, you see that there's 6, there's 1, there's a lot of other types here. So I want to say where type is in. I want to group by, of course. Every time you see some sort of like aggregator like average or maximum or minimum, there's a good chance you may want to use the group by. So if you say find a type where the maximum spot time, then you want to group by, because you want to group by this one and then find the average. So there's a good chance you want to do something like that, right? So group by, so in this case, we'll group by type. And then finally, let's also, I think this is probably good enough. It's quite of elaborate already, but I could still maybe have a few more. I could maybe have an having, so I could say having, and having average, or you could either use active time average, or you could just say average, and then you can put spot time as well. So this will both work. Let's say greater than 100. So only for any spot time that is more than 100. Anything less than 100 seconds, I want to take that as a miscount, maybe mistracking. So sometimes I wear my wristband and accidentally before I actually mean to begin the activity, I tap on the wristband and it starts tracking, and then I quickly close it down. So anytime there is a spot time less than 100 seconds, I want to take it as a sort of erroneous data entry. I don't mean to track that. So I'm going to close the string now. So I have a query string, right? You can compose this. You can have it as elaborate as you want. All right. And then you could say DuckDB.query, just like what you see up there. And then you just have to put in your query string. So query string like this, right? And run that. And now it's going to give you the results. It's going to give you the relation tree, the results column. And this time results column are not going to print out everything now. It's going to only print out the 2 columns that it returned to you, because you only asked for these 2 things, the time and the active time average. So it tells you type is going to still be a big integer because it's still going to be 6 or 1. It's an integer. But active time average, that's going to be a double because there is decimal points and you're counting mean and stuff. Now that's the results preview, and it's going to tell you that first for activity number 1 for yoga. Now I don't do yoga. I'm just giving you some. Number 1 actually stands for, I think, running. Number 6 I think stands for jogging or walking. So you actually this is the mean, the average. It's 275, and then this is 1,430 seconds. All right. Even cooler is that what if I want to take this result and I want this as a data frame? I want this output to be a data frame. Then I can just have this assigned to a new variable like out, and then I could take all of this and I can chain them to 2df. So what it does is that this actually returns a set of columns, right? A set of lists. And really, when you know what data frame is, pandas data frame are actually composed on NumPy arrays. Basically, data frames are just a list of lists in a way, a list of array. Kind of the same in R. In R, a data frame is a list of lists. So data frame in R is a list of lists. So when you see something like a lot of Excel, when you open up an Excel file, you want to imagine each column being a list A, list B, list C, list D, and data frame is a list of all those lists. And same thing in pandas, data frame is basically a list of, or a list of many series, right? Many pandas series. And basically series are composed of NumPy arrays. So this is basically sort of the same design philosophy in R and in Python. And when you do this, you say, take this db.query to data frame. What it does is that because it returns that in each of the columns anyway, you could take this and then it can quickly compose a data frame back to you. So I'm going to just run all of this, and now I can print out. And now this is just a data frame, right? I can use out and can say describe, because if this is a data frame, I can do that. So I basically use my SQL, I take a CSV in there, I compose my query, and then I have the result output to me as a data frame as well. And you notice that how this whole time you're actually not making a database server. You have the power of this incredible database technology, the query plans, writing all this query, select, join, where, having all of this stuff, the optimizations, the relations tree, and the developers are actively adding a lot of new features to it for scalability, for parallelism and stuff, right? You're doing all of this stuff without actually provisioning or creating a database server. You're not having, I didn't ask you to go into a terminal and then create a new database server, keep it running, and then make a connection and do all of this stuff. You didn't have to do any of that. Right? So this is really, really cool. I think I should also mention at this point, there is also this exciting project also by DuckDB. It's an extension to read SQLite databases. So this allows you to use DuckDB to directly read data on from a SQLite database file, and the data can be queried directly. And the data can be queried directly from the underlying SQLite tables or read into the DuckDB tables. So you could also just go ahead and just do all of this, select from, do all of this stuff directly from DuckDB itself. Okay, so if you find any interest in trying to use DuckDB on and another project, I want to actually go into the last project here. This is a bare bones example of querying with DuckDB WebAssembly using White and using the browser, no front-end framework. So if you want to bring DuckDB in, you're a front-end developer and you're trying to have a embedded browser technology, trying to explore different options out there, then I recommend you take a look at this one. You can also have it without any kind of framework. So this is no front-end framework. So there is just quick instructions here, quick guide on how to install the dependencies. But again, if you find this very interesting, you could this is all great. If you truly understand the mental model in here, this is actually really profound. Basically running the whole having an embedded database directly in your browser, directly WebAssembly level, and then or whether in your notebook itself, or whether what you see here, there's so many different examples, so many different use cases. You want to see more content on this? You want to see more examples of that? Let me know in the comments, and I'm happy to maybe find time to work on that sometime in the future. So that's kind of it. That's a quick introduction to DuckDB. I hope that's educational and that you learned something new today. So I'm gonna catch you in the next video.